This production is brought to you by the University of Edinburgh.
Hello, and welcome to an interactive introduction to MATLAB. This screencast will outline how to use script files in MATLAB. A script file is essentially a text file which contains a series of MATLAB commands which you can execute in the command window. The reason script files are useful is that if you have a large number of commands to execute, you can put them into one file while also saving your work to the file to reuse at a later date if required. So, to create a new script file, we go to the toolbar, choose New Script, and now you can see that it opens an editor window and we can start entering our script here. But before we do that, I want to show you how to make a small change to the MATLAB desktop which will allow you to work with scripts easier. If we look at the right-hand corner of the editor window, you'll notice that there is a little icon which shows specific actions for that window. If we click the Dock Editor key, you'll see that the editor becomes docked into the MATLAB desktop window. This makes it easier to create scripts and run them all from the one window. So the script that we will write for this session is based on one you've already come across in exercise 2, question 7 regarding points on a circle. The first thing we have to do before we enter the commands to our script is to put some comments at the top. This will give a name to the file, explain its purpose, supply a date, and explain who authored the file, as well as describing what variables will be used within the file. To enter a comment into a script file, we enter the %, which tells MATLAB not to execute that line as a command. I will first enter a name for this script, in this case, mycircle.m. Next, I will add a description of what it does, in this case, a script to plot points on a circle given the radius. I will also add my name as the author and give a relevant date to the file. The next thing we do is write a variable dictionary, which should be fairly easy for this example since we're only using a handful of variables. It's a good practice to do this because if you wanted to return to this script at a later point, you will be able to see quickly what each of the variables do. It also makes it a lot easier for other people to use your scripts, especially once you have started creating long, complicated files. The first variable we'll put into our dictionary is r, and that will be the radius of the circle. Next, we enter x, y, and they will be points on the circle. We need to have a vector named theta, which will hold some angles. These will of course be in radians because that is the default of the angular measurement within MATLAB. These are all the variables we require at the moment, so we'll move on to the main function of the script. It is good practice to start your scripts with the clear all and the CLC commands to make sure that any workspace variables and your command window are cleared so it is easy to see what output is being generated by your script. The first thing we want to do is get the radius of the circle from the user and assign that the variable r. The way we do this is to use an input command which requests input from the user and assigns it to a variable. Within the input command, we can use a string of text to prompt the user, in this case, enter the radius of the circle. You will notice that the string is enclosed in single quotes, which are always the case for strings in MATLAB. We terminate with a semicolon so that it does not print, and the next thing we do is define theta, our vector of angles. For this, we will use the linspace command. Theta will start at 0 radians, go to 2 pi radians in 50 steps. This will give us 50 points on our circle. Once again, we finish with a semicolon. Now that we have the radius and theta defined, we can calculate the points x and y. X is defined as x equals r cos theta with a semicolon. Y is defined as y equals r sine theta, again with a semicolon. The last thing we want to do for this script is to plot the results. So to create a graph, we need to type what is to be plotted, in this case x and y. Create equal axes with the command axis equal, label the axes with the simple command x label and y label, and finally use the command title to give it a name, points on a circle. We could have completed this annotation interactively, but then it wouldn't be saved in our script for reuse at a later date. Entering these commands now will save time in the long run. The script is now finished, so we'll save it as my circle. Once saved, we will now execute the script, and there are a couple of ways we can do this. The simplest method is to use the play button on the toolbar. The command window is now asking for the radius of the circle, so we will enter 2. MATLAB then displays our plotted circle in a figure window. So before we finish this session, I would like to show another way of executing the script. We can type its name into the command window. MATLAB then finds the script and runs it as it did previously.
This production is copyright The University of Edinburgh.